Hello, welcome everyone. We're going to do some tests on your microorganisms. Okay, I asked you guys to please read the materials, and I'm going to start with the biochemical test of microbiology. Okay, overview. Why would you do this? A lot of things that you're doing right now has to do with identification of a microorganism. So when we studied staining, it was to identify a microorganism. Now we're going to use biochemical tests in order to identify a microorganism. I got to say also that studying metabolic tests in microorganisms helps us understand ourselves because we run a lot of the same metabolic tests. Okay, so as a nursing student who is interested in the welfare of their patient and is interested in physiology, studying the metabolism of a microbe is essential in helping us understand our own physiology. So this is not just an abstract exercise. It's supposed to help you think through how both microorganisms and ourselves work. And again, the application is to help us identify a microorganism. So with that introduction, with the biochemical tests that are introduced are TSI, which is triple sugar iron, okay? So triple sugar iron has glucose, lactose, sucrose, and iron. And what it's doing is testing the organism's ability to catabolize or break down all of these sugars, okay? Everybody can break down glucose, but not everybody can break down lactose or sucrose. So in fact, typically with bacteria, only coliforms, fecal coliforms can break down lactose. And then the iron is supposed to detect the presence of not obligate anaerobes, but anaerobes, okay? So if you remember, one of the descriptions for an anaerobe is a microorganism that either does not use oxygen or uses something other than oxygen as a final electron acceptor. So with these, what we have is we have an iron moiety that's very heavy. And if the microorganism undergoes sulfur reduction, in other words, is using sulfur instead of oxygen in order to carry out the electron transport chain, then it'll form a complex with the iron and the media, and it'll turn the media black. Okay, it's a very rewarding outcome. My students here love it. So that's what we're doing. Oxidase, okay. Oxidase, we're assessing the presence or absence of certain cytochromes in the microorganism. Again, some microorganisms have the ability to carry out oxidase reduction, some do not. And then catalase, we're looking for the ability of a microorganism to break down toxic forms of oxide like hydrogen peroxide. And again, some microorganisms have that trait and some do not, okay? And that trait is a trait that is necessary for them to protect themselves against toxic forms of oxygen. So we're going to start with TSI. Look at all the things that can happen with a triple sugar iron. So this is going to be your interpretation table once you're finished, okay? And let's start here at this is actually pretty easy, okay? So I'm going to switch cameras here, I believe. Let's see if I can do this without doing something terrible. Okay, I think that worked. Let's see. Okay, so here, I've got my materials here, okay? And this is, I just grabbed a rack of items because I happen to be lucky enough to have everything that I could ever need here. I make my own triple sugar iron. Let's see, can you see that? There we go. I make my own TSI. I make my own, well, everything. So what you're going to do, hopefully, in the time that you read this, you became aware that, we better make sure that we have E. coli, Staphylococcus epidermidis, and Micrococcus luteus back in suspension, okay, revived. I know that we've done E. coli, we've done Micrococcus luteus. I don't think we've done Staphylococcus epidermidis. So same way of bringing, rehydrating this guy as the others, okay? We need to get this one up and going in order to do this experiment. So those are 3 different organisms that we're going to use, okay? If you have a slant of each one, that's great. You should, at the very least, because you're rehydrating, you should have a tryptic soy medium, a broth, okay, that has the organism in it. So you have 3 of those, 2 that you had already prepared, E. coli and Micrococcus luteus for a previous experiment, and then the 3rd one, which would be the one that we made for this experiment, which is Staphylococcus epidermidis. Okay, so you should have 3 of those, and what you're going to do is you're going to inoculate 3 tubes, 3 TSI tubes. Now, mark your tubes before you inoculate them. I'm noticing people are making mistakes in which they're adding microorganisms when they're not supposed to because they lost track of what they're doing. Label your tubes first, then add your microorganisms. Otherwise, you're going to make mistakes, okay? So once we have your 3 microorganisms, I'm going to simulate how to do it here, okay? That's the whole purpose of me doing this little presentation. So you're going to take your little baby lamp here, okay? There it is. You guys see it? You can't see it, can you? Bad contrast. How about now? Can you see it now? There we go. Okay. So what you're going to do is you're going to take a clean loop, okay? And if you don't have anything else for the microorganisms, you should have the tryptic soy broth, okay? So what you're going to do is you're going to take this out of the sheath. Okay, you're going to take this out of the sheath and take your tube with your microorganism. You're going to uncap it, and I don't know if you guys remember how I do this, but I grab the back, use the back of my hand like this, and I unscrew it just like so. And then I take my loop, and I like to shake the loop inside because organisms have a tendency to settle to the bottom, okay? So I'll shake it inside to get a nice uniform solution. I'll take it out gently, okay? I'll flame my tube, okay? So flame before and flame after. I think I forgot to flame before there, I apologize. And then you're gonna grab your TSA tube. You're gonna do something peculiar with this, okay? We're gonna uncap it just like before. We're gonna flame it, okay? And I'm gonna bring this up so you guys can see what I'm doing. I'm gonna put my loop in there, like so. And what I'm gonna do is I'm gonna go through the media all the way down. Easier said than done. I'm having trouble doing it right now, actually. There we go. I'm gonna go all the way to the bottom. Don't twist the loop. Go all the way to the bottom. And without twisting the loop, gently pull it up. okay? And now you're gonna take the fluid here and you're gonna do a nice little zigzag back and forth. You go like this. Do you guys see my zigzag? A little zigzag back and forth, 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 back and forth. All the way up, just like that. Once I'm done, I'm gonna flame my tube and I'm gonna recap it. Okay, this lube goes into 70% isopropyl alcohol. Boom. Okay, why do we do what we just did? Well, you have a deep butt on the tube, and what we need to do is we need to study both the anaerobic traits and the aerobic traits. So the anaerobic traits are studied by putting the organism inside the media where no oxygen arrives, and the aerobic traits are studied here. So the sugar catabolism is going to appear here, but if this guy decides to use sulfur because there's no oxygen here, that sulfur reduction, that blackening is going to happen at the bottom. So we're studying two different traits on the TSI. We're studying the anaerobic traits in the deep butt, and we're studying the aerobic traits in the slant. Very neat. Once you've done that with one microorganism, you're going to do it with the other two. Something that people forget to tell you is that once you've done this, make sure that the cap is only finger tight. Because if you put it very tight, no oxygen is going to arrive in here, and it's going to take longer for your microorganism to grow. So make sure it's nice, just finger tight, nice and loose, so that oxygen can go inside, and then go ahead and do your other two. Okay? So that is it for the first part. We'll come back in just a second to do the other two. Okay, so now we're going to do the second part of the exercise, which is to determine whether the organism is oxidase positive or negative. And the first thing I want you to look at is page 4. Let's see if I can make it bigger. Oh, this is nice. Page 4, where it shows you that if there's no reaction, then it stays amber, which is the color of the oxidase reagent. But if it's positive, then it turns a purplish color. Okay, that means that there is cytochromes that are reducing oxidase in the organism. Okay, so when you're being told to watch for an oxidase positive organism, you're being asked to look to see if there's a reaction that causes it to turn purple. Okay, so now that we have that, we're going to go to a little part of your, somewhere down here. There it is. I'll make it a little bit smaller so it fits. Okay. And you're supposed to take a little piece of filter paper. Okay. You're going to take a pencil or pen and divide it in thirds. There it is. You're going to label it. By now, you should become aware of how important it is to label things correctly. So one is going to be S. epidermidis. One is going to be Micrococcus luteus. One is going to be E. coli. Okay. Now, I tell you to put a bunch of paper towels underneath it because you don't want this stuff leaking onto your counter surface. To be honest, right now I don't care because I'm simulating everything. I don't have a single microorganism near me right now. These are all simulations, just so you know what you're supposed to do, okay? But it doesn't hurt to put plenty of towels underneath it, so that when this stuff goes below the filter paper, you can clean your counter, and your counter stays clean. Okay. Now, I'm not going to do it. And the reason I'm not going to do it is because if I put white paper under my filter paper, you're not going to see my filter paper. Just, I need the contrast of my table, okay? But you do not do that. You're going to put something underneath it so it just doesn't go underneath. Okay, now what are we going to do? Well, you're going to take a fresh loop. You're going to take your organism. I'm going to start with fake Staphylococcus epidermidis. Remember, I'm simulating all this. Back of the hand. Okay, you're going to open your tube. You're going to flame it on your low lamp. Boop, boop, boop. You put your nichrome loop in there. Shake it a little bit so you can get a good amount of material. Okay, flame your tube. Whoop, whoop, whoop. There we go, 3 times. And now what we're going to do is we're going to put that on here. Just like so. It's not a lot. It's not a lot. Okay. This goes into 70% isopropyl, 90% isopropyl. And then, okay. And then what you're going to do is you're going to take your oxidase reagent, okay? Get your watch. By watch, I mean your cell phone. Get your cell phone. Put a timer on there, and the times that you're looking for is 10 seconds. Okay. If there's a color change in 10 seconds, then this is a positive oxidase test. And then the second time that you're looking at is 60 seconds. Okay. And we say that that's a delayed oxidase positive. So put your little timer, click start, add your 5 drops of catalase, of oxidase reagent, 3, 4, 5. Wait 10 seconds. If it turns purple, annotate that. If it doesn't, wait 60 seconds. If it turns purple, annotate that. And after 60 seconds, if nothing happens, annotate that. Those are the 3 outcomes. It turns purple within 10 seconds. It turns purple within 60 seconds. It doesn't turn purple at all, okay? And if you notice, I'm actually not happy with this. Do you see that? That took my entire quadrant. I don't like that. So next time I do this, I'm going to add 4 drops of the oxidase reagent to make sure it stays inside my quadrant. But that's it for this part, okay? And I'll be right back for the last part. Okay, so this is the catalase test. And for the catalase test, you're going to need 2 slides. This is what my slides look like. 2 microscope slides. Yours will probably look a little bit different. Okay, so 2 slides. And I'm going to take my little pencil, and I'm going to draw a little line right down the middle. Okay, that worked out really well. And what am I going to do next? That's right, I'm going to label it so I don't forget what's what. E. coli. I keep on saying that because some of you have been complaining about mixing the wrong stuff together. So if that's the case, then you really need to label everything that you do so you don't make that mistake. Okay, so there it is, epidermidis, luteus, E. coli. My E. coli doesn't look so good. Let me do my E. coli again. There you go. All right, there's my E. coli. Okay, just as before, we're going to take a clean loop. You guys should be getting tired of hearing me say this. We're going to take my broth, my tryptic soy broth, okay? I'm going to start with a simulated E. coli. So I'm going to open this with the back of my hand. I'm going to flame it, 1, 2, 3, okay? And stick my brand new loop in there. There it is. Stir it. Make sure I get good number of bugs in there. Take it out gently, flame it, 1, 2, 3. Okay, that looks good. And now what I'm gonna do is I'm gonna put that little dab right here on my fake E. coli right here. Come on. Oh, that looks good. Where does this go? That's right, 70% isopropyl. Bam, there it is. So if you look on here, you'll see that I just put the tiniest, see my little drop? It's just a tiny little drop, very little. Okay, now I'm gonna add a little bit of hydrogen peroxide, okay? So hydrogen peroxide, and you should see an immediate reaction if it's positive. There you go, I have my hydrogen peroxide. And if I have a positive reaction, what am I supposed to see? I'm supposed to see bubbling. The bubbling is the presence of catalase in the organism that's breaking the hydrogen peroxide into water and oxygen. Just like your blood has catalase, when you fell off your bike when you're a little kid and your mom came over with hydrogen peroxide and you put it on your arm and it fizzed all over the place, that fizzing is a catalase in your blood breaking the hydrogen peroxide into water and oxygen. That means that you are catalase positive. Now we're trying to test if these guys are catalase positive. Okay. So you're going to do 1, 2, 3 for the 3 organisms. You're going to add your hydrogen peroxide. We're going to look for bubbling. If there's bubbling, then it's positive, and if there isn't, there isn't. So if you can take pictures of that, that would be great. Here's the data sheets. Okay. So here's oxidase, here's catalase. These, you can record the outcomes as soon as you're done with the exercise on the oxidase and the catalase, because here you're looking for a color change, okay? However, for the first one, you're gonna have to take those TSI slants, okay? These little guys that we did, those 3 of them, and we're gonna have to leave them at room temperature for 2, 3, maybe 4 days, okay? In order to have the TSA actually get good growth in it, and then we can go back to this chart. The chart is on page 5, and we're supposed to look at it and go, okay, so the slant is yellow, okay, and the bud is yellow. So that means that this particular organism fermented glucose and lactose and possibly sucrose. And so the interpretation is AA, okay? That's the way you would read it. So you're gonna take a look at your tube once you've had growth on there and use this interpretation table to find out what happened, okay? Very neat. Now, I had a person here suggest if these people are taking very long in having growth in their inoculums, instead of having them sit somewhere in the room, if they can wrap it up in something safe and put it behind something warm. And the suggestion, I don't even know if this is a good idea, okay? But the suggestion is to put it behind a refrigerator or behind a freezer. So you will know that behind a refrigerator and behind a freezer, it's really, really warm because those instruments are pumping heat out of the inside of the box. So that would be a great place to put these because we're trying to reach 37 degrees centigrade or 98.6 degrees Fahrenheit. In other words, the same temperature that our bodies have, okay? And if you reach that temperature, then these things will develop in a day. They'll develop overnight. And then you guys don't have to wait 2, 3, 4 days at room temperature, because that's really slowing everybody down terribly. That's a big hiccup that I finally figured out. So if you guys can find a warm place, like behind a refrigerator, be careful that the darn things don't fall and break, or behind an ice box, okay? That would be great. If you can think of other ideas, let me know so I can share it with your peers. But we want something that's nice and warm so that these things can incubate at 37 degrees and we know what happens in 24 hours instead of 4 days, okay? So that's it for now. I'll come back to talk about the other experiment later on today. Thank you for your attention, ladies and gentlemen.